Dubai real estate market is always changing. New infrastructure, metro stations, and tourist attractions can drive property price up. But by how much? Where should investors put their money for the best return? Traditional real estate analysis is limited. It looks at past prices, but it doesn't predict future trends. That's where data science comes in. My goal was to build a model that not only explains how infrastructure affects property price, but also predicts which neighborhoods will grow the fastest by 2030. To do this, I used a structured data science approach, collecting data, cleaning it, exploring trends, and building predictive models and evaluating the results. Let's start by understanding why this is a data science problem. Predicting real estate trends isn't simple. There are too many variables: proximity to metro stations, rental demand, tourism, and upcoming development. To make sense of all these factors, we need data science. This problem involves large and complex data set. Property values don't just depend on location. They fluctuate based on dozens of factors like infrastructure, amenities, and historical price trends. Patterns in real estate price are non-linear. For example, a new metro station might not increase price instantly. It may take from 1 to 2 years before the effect is noticeable. We need machine learning to capture these delay trends. Forecasting price growth requires predictive modeling. Investors want to know which areas will appreciate in value by 2030. This is a classic data science problem. Predict the future outcomes using historical data and external factors. Now, that's what we understand that challenge. Let's move to the data preparation process. To build a reliable model, I worked with 4 key data sets. Firstly, property transaction from 2010 to 2024 to analyze price trends. Second is rental contracts to calculate rental yield and investment potential. Thirdly is metro stations and infrastructure data to quantify accessibility impact. Fourthly is tourist attraction dataset to measure how proximity to landmarks affects value. However, like any real-world dataset, there were issues, missing values, inconsistencies, and extreme outliers. Here is how I handled them. Firstly, missing prices, estimated using interpolation and external government data. Secondly is inconsistent formats like standardized dates and currency units. Thirdly is outliers removed by using IQR filtering to eliminate unrealistic values. With clean data, I moved on to exploratory data analysis to uncover key trends. EDA helped reveal hidden patterns in how infrastructure affects prices. Here are 3 major insights. First, of metro stations drive higher prices. Properties within 500 meters of a metro station had an average price increase of 12 to 15% compared to those farther away. Secondly, is tourist attractions increase rental demand. Apartments near major malls, beaches, and landmarks showed higher rental yields, confirming that tourism plays a role in real estate pricing. Thirdly, infrastructure developments have long-term effects. For example, properties around the Expo 2020 site saw a sharp increase from 2019 to 2023, proving that new developments impacts price over time. These insights were useful, but I needed a way to predict future price changes. That's why I applied machine learning. Choosing the right approach was critical. I tested multiple machine learning models and I selected 2 that were most suitable for solving this problem. First is random forest regression. It captures complex price trends that linear models cannot. Secondly is handles missing data and price fluctuations effectively and achieved an R-square score of 0.85, meaning it explains 85% of price variations. Second is k-means clustering. Segments neighborhoods based on historical price trends and helps investors identify high growth versus low growth areas. So why is this approach the best? Random forest works well for real estate forecasting because it learns from historical patterns and infrastructure impacts. And k-means clustering identifies areas with similar price behavior, allowing investors to compare neighborhoods objectively. Together, these models give a powerful way to predict future property values and classify investments hotspots. Now, let's discuss the results. The model produced some valuable insights. First, the highest ROI areas today are Business Bay, JBC, and Al Furjan. Second is properties near metro stations saw a 12 to 15% increase in value. Thirdly, the model predicts these areas will grow the fastest by 2030. Dubai South has 25 to 30% increase because of the new airport expansion, and Deira Island has 18 to 22% increase because of the beachfront development, and Al Furjan has 15% increase because of the metro expansion. This proves how data science can not only explain market trends but also predict future investment opportunities. Now, let's conclude with key takeaways. In summary, this project demonstrates that real estate pricing isn't random. It follows pattern that can be analyzed and predicted using data science. Machine learning models can forecast price growth, helping investors make informed decisions. This approach can be extended beyond real estate. It can be used in urban planning, smart city projects, and tourism forecasting. Finally, let's wrap up with how this project reflects my skills. This project highlights my ability to work with messy real-world data, apply machine learning, and generate meaningful insights, whether in real estate, business intelligence, or predictive analytics. I enjoy using data science to solve problems. Thank you for listening.